Trying to explain about the working principle of a DC motor, the current in the DC motor direction, how it is going to flow in this. So basically a DC motor consisting of two magnets like North Pole and South Pole. In between the two magnets, we have a coil, single loop coil we can say. The both side of that square part is called brushes, from which the input power supply is given as input to the coil. So by connecting plus and minus to those two brushes, and at the part of that commutator, that round shape one is called commutator, there it is going to convert, change the form of DC form into AC form, and that AC is applied to the coil. Even it is a DC motor, to produce, everyone knows that a current carrying conductor will produce the magnetic field around the conductor. So when it is subjected to current, the current which is flowing through the coil, it will produce the magnetic flux around the conductor, and that current carrying conductor is placed in between magnetic field, North Pole and South Pole. It is a permanent magnet, so by virtue of its nature, it releases magnetic flux from North Pole to South Pole. Within that magnetic flux, we are placing a current carrying conductor. Again, current carrying conductor will produce the flux. So we have two types of fluxes. So one type of flux is from magnet, that is North Pole to South Pole, whichever releasing the fluxes, and the other type of flux is produced by the current carrying conductor. When two fluxes are interacting with each other, a force is exerted, and that force perpendicularly acting on the conductor, which pushes the conductor to move in the direction of current. So thus the rotation starts in the conductor. So this is about the pictorial explanation of the working principle of the motor. Okay, this type of diagrams are drawn on the board when the theory classes is conducted. So there, this type of diagrams will be there. But the advantage of this explanation, we are going to see the live parts of those magnets. Basically, motors are two types: permanent magnet type motors and temporary electromagnetic type of motors. We have two types of magnets, which are permanent magnets directly available inside of Earth. We will extract those magnets from the Earth. But the other type of magnets are called electromagnets. So if you take a magnet, the molecules are all arranged in the sequence manner. Molecules are all arranged in the sequence manner. Thus, every molecule's North Pole is attracted by the corresponding molecule South Pole. There exists the attraction force because of the molecules arranged in the sequence manner in the magnet. That is not there in iron piece. Iron piece is having randomly arranged. When it is connected to DC supply by means of a current wire wound on the iron piece, when DC supply is connected to that iron piece, it will arrange all the molecules in a sequence mode, just like in the magnet. So thus magnetic property created in the iron piece by arranging all the molecules in a sequence mode by using the DC current. So that type of electromagnets are used in the DC motors. The purpose and the application of using electromagnets is you can control the magnetic property by controlling the input excitation current, which is DC. If you increase the current, magnetic property also is going to increase. If you decrease the current, magnetic property also going to decrease, because field current, the excitation current, magnetic property will depends on the excitation current. But in a permanent magnet case, the flux flowing from North Pole to South Pole is always constant. Within that strength, it is going to release the amount of flux. Neither it can be decreased nor it can be increased. So that is from the permanent magnets. The advantage of electromagnets is by controlling the field flux, you can increase the speed of the motor. So speed variation is possible in the DC motors by controlling the excitation current which is given to the magnetic field coil. So N is equal to EB by phi. Flux decreases, speed will increase. There is an inversely proportionate between speed and flux. When flux decreases, speed will increase. When flux increases, speed will decrease. So with that, by controlling the excitation current which is given to the magnetic field coil, since it is an electromagnetic field coil, the current which is given to the electromagnetic coil, by controlling that current, you can increase the amount of flux and also you can decrease the amount of flux. By increasing the flux or decreasing the flux, speed varies. The speed variation is possible in the electromagnetic type of motors. Wherever in a permanent magnet there is a constant speed. Neither we can decrease the flux nor we can increase the flux. So this type of pictorial representation part, every part we are going to see live in the motor, because we have some equipment and there it is. So every motor is open condition. You can see live parts when it is running also. We can give the power supply and run the motor. While working, we can explain the concept of working principle. Here, whatever I explained here by showing the original motor. So there is a small DC motor is there in my hand. So you can see internal parts of this DC motor. This is the armature, you can see. These are all the iron core, and these are the armature conductors which is connected to the copper segments of the commutator. This is called shaft, and this is coolant fan. So which will give air circulation to the heated up armature conductors. And you can see these two are the permanent magnets situated inside of this coil. So these two are the permanent magnets. There is no winding since it is a permanent magnet. So directly by virtue of its nature, it starts releasing flux from north pole to south pole always. Speed of this type of motors will be constant, because we already explained that N is directly proportional to EB by phi. Phi means flux. Flux is in denominator, so inversely proportionate relation is there between speed and flux. If you decrease the flux, speed is going to increase. If you increase the flux, speed is going to decrease. That is not possible in permanent magnetic type of motors. Right. So I explained you this is the electromagnetic field coil. So basically we earlier we discussed about the motors classified into two types, depends on the input power supply, AC motors and DC motors. So AC motors we have seen already. So when coming to DC motors, there are basically DC motors are classified into two types: separately excited DC motors and self-excited DC motors. So I'll explain what is separately excited, what is self-excited. So the current which is given to the magnetic field coil, electromagnetic field coil, is called excitation current. So the current which is given to the magnetic field coil is taken separately from other source, and the current carrying conductor will take some other source separately. So there is a separate power supply for the armature conductors, and there is a separate power supply for the magnetic field coil. So this type of motors are separately excited, because it is taking power supply from a separate source, not from common source. So this is given separately, this is given separately. So basically DC motors are divided into separately excited DC motors. In case of self-excited DC motors, there will be a connection between magnetic field coil and armature. Since I explained you, there will be two terminals of the magnetic field coil, and there will be two more terminals for the armature field coil. If you connect armature two terminals parallelly with the magnetic field coil of the electromagnet terminal parallelly, so you have a connection between, suppose the starting terminal of the field coil is taken as F1 and starting terminal of the armature is taken as A1, ending terminal of the electromagnetic field coil is taken F2, and ending terminal of the armature coil is taken as A2. So you have a connection between F1 and A1, F2 and A2, and common power supply is given. Same current is going to flow through the magnetic field coil as well as armature conductor, since we have a connection between magnetic field coil and armature. So same current will flow, and the purpose is fulfilled in the magnetic field coil, and same current will flow through the armature conductor, which is going to create the flux by the current carrying conductor. So with the interaction of two types of fluxes, a force perpendicularly acts on the coil of the armature and pushes the conductors to move. Thus the rotation or turning or twisting movement obtained in the shaft. Thus the rotation starts in the motor. Now when coming to the working principle, it works on Faraday's laws of electromagnetic induction, states that whenever a current carrying conductor placed in the magnetic field. There are two types of magnetic fluxes. One flux is produced by the electromagnetic field coil. The other flux is produced by the current carrying conductor, which is given input as a DC supply to the conductors. So there are two types of fluxes interacting with each other and exerts a force. That force in mathematically it is represented as F is equal to VIL sin theta. That force perpendicularly acts on the conductor and pushes the conductor to move. Thus the rotation starts in the motor. This will be a question basically. Explain the working principle of a motor. You have to explain this. As per the statement, the Faraday's laws of electromagnetic induction states that whenever a current carrying conductor placed into the magnetic field, it experiences a force because of the interaction of two types of fluxes, one from magnetic field coil, other from armature conductors. It is a current carrying conductor. So thus the rotation starts in a DC motor. So depends on the input power supply. We discussed as AC motors and DC motors. Depends on the excitation methods. DC motors are divided into two types: separately excited and self-excited. So depends on the connection in self-excitation. Separately excitation, there is no other variant because we have no connection between field and armature. In shunt, we have a connection between field coil to armature. If it is parallelly connected, that means F1 to A1, F2 to A2, parallelly connected, it is called shunt motor. If the winding coil is connected in series with the armature, if the winding coil is connected in series with the armature, it is called series motor. If a motor consisting of shunt field as well as series field, both in a single motor, it is called compound motor. So, depends on the excitation. Self-excited motors are divided into three types. Depends on the connection between field coil and armature. Parallelly connected means shunt motor. Series connection is series motor. If a motor consisting of series field as well as shunt field, both in a single motor, it is called compound motor. Three varieties of motor. Again, compound motor is connected: long shunt compound motor, short shunt compound motor. If the shunt field is connected across with armature field, it is called across armature as well as series field. There will be a series field in series with armature. There will be a shunt field parallelly with armature and series field. So it is called long shunt. If the armature terminal connected across only shunt field, it is called short shunt. So we have another two types of compound motors: cumulative compound motor, differential compound motor. Cumulative compound motor is, there is a series field I already explained, which is in series with armature. If series field is properly connected, that means YY is connected to A1, A2, it is called cumulative compound motor. If the series field is reversed and connected to the armature, it is called differential compound motor. These are the two types of compound DC motors.